Right. So I let me just start off that I've never done this before. I've never done a voice recorded demo. I've done live demos. Those are completely different. I've done like one-on-one, one-on-five sort of presentations on prototypes, but I've never really done something which sort of, it's like a thing that is going to be out there, um, and it isn't live. So I'm going to try and not go on a lot of tangents. That's what I'll try to do. But other than that, let's just dive into it. So, what is in front of your screen is an assistant diagnostician. It's quite basic, but I think it's quite interesting because it sort of combines an embeddings model and traditional ML regressor, and it does that quite elegantly. Is what I'm trying to get at. And I'll tell you how it does it. I'll tell you how I managed to sort of deploy this and then have it talk to an LLM which is running on a private server, all of that sort of jazz. So one of the great things about embeddings model is you can either have one that is running on your local machine, or you can sort of subscribe to one. So within this app, I have sort of configured 3 of the most common LLM providers or AI services providers: Mistral, OpenAI, and Gemini. So France, United States again. And to compete with all of them, I have a local one. So you can download any one of these models, have it run on your machine, and then talk to it from anywhere. And the way that I've done the talking part from anywhere is through ngrok. So it's a very nice little software. You can download it, quickly configure it, and have your local LLM run on an LM Studio type application, which will launch it behind a private server and a specific port. And then ngrok is going to put that on the web. So it's going to generate a URL for you, and then whoever has the URL can sort of talk to your application. And that's what I've done. So this is my little URL. As you can see, it's already connected. I have 3 models that are running locally. I'm going to use the embeddings one. Lucky for us, I've already done this, so we're just going to dive right into it. Now, what kind of data does this take? Well, this is it. It's a very simple, unstructured data set. Conditions, your symptoms, and then here are the embeddings that I'm talking about. So what my model does is breaks these texts into different vectors. I have like 700 and something embeddings, and I of course label encode my label so that I can train a regressor on it. Now the cool thing is that since I've already sort of processed this, I can show this to you, or any sort of you can show this to anyone in terms of what these embeddings look like in a 3-dimensional space. Now I'm going to run some clustering behind the scenes, and what you're going to see in front of you is how well separated these diseases are. Because you can think about these diseases in terms of symptoms. They're quite overlapping. Some symptoms for migraine could also overlap for some symptoms of, I don't know, dengue fever or something like that. So there's a lot of overlap. So to get distinct clusters out of them is quite hard unless you know how to embed these, And as you can see, I have quite distinct clusters. So if you look at this from the top view, I have, spondylosis, polarisis, I don't know, there's a lot of 24 different diseases, right? With overlapping symptoms, if I may. Now, all of this is made possible because of my embeddings. And now I'm just going to train a simple ML. It could be logistic regressions, as simple as a logistic regressor on this. And what that is going to do is it's going to allow me, or anyone that is using this app, to ask some questions in forms of symptoms and get a diagnosis back. Now, of course, this is not a doctor, but what this helps, and a mentor of mine sort of coined it in a way that makes so much sense. It's not going to replace what diagnosticians do. It's going to help them not to miss anything, so to speak. So that's the idea. So I'm going to train my model, and since it's such a, after the embedding it becomes so clear and so sort of structured, our model performs exceptionally well. And the cool thing about this, which I feel sort of makes this into a self-improvement type of system, is that it stores a user's history. So if we go and type up our symptoms, so let's say severe headaches with photophobia and a rash on my skin. This is, this is an example. I'm going to hit diagnose, and it's going to give me a diagnosis and a confidence interval associated with that diagnosis. So anything that is like red is like it's not really sure about, right? Let's send another one which define our symptoms quite clear. So fever, insomnia, I'm really not good with spelling ones. I mean, if I'm coding and all of that stuff continuously, my English spelling stuff goes away. And headaches, I'm gonna hit diagnose. So dengue fever, right? I'm gonna give another one so I can show you what the history looks like, right? And this is gonna be skin rash, fever, and okay, what can we say? Stomach ache. Something for, right? Again, dengue fever. Now, it's going to give us some information, what it is, what are the common sort of causes, what are typical symptoms, some preventative measures, and some immediate relief, Nothing to be up and arms about. Now see, this is what's quite interesting. So anything, I'll speak to you about this confidence interval and how you can sort of reset it. But you can download this history. And the cool part about this is, say if this app is used by a specific region, or in a specific region by a group of people, and you see on the back end what sort of symptoms are being shot at this app. So what that would allow you to do is do some analytics on it. What disease is in its primary stage throughout, sort of rampaging through that population. And instead of being reactive, you can be proactive, because after a specific disease, what follows? What sort of treatment? If people are Googling symptoms, or people are using this app to sort of understand their symptoms now, within day 2 or 3, how many of them are going to queuing up for medicines? Stuff like that. And then how many of them are actually going to go to the doctors for proper diagnosis, and how many of them are going to actually need intensive care? So instead of being reactive and waiting for the people to get to those points, we can sort of predict some of those things if we know what the population in a specific region is sort of feeling at this point through this app. And we can configure the model's prediction, based on quite clear confidence threshold. So if I trust my model, I want to trust it within a specific range of what it's confident about. So this could be anything between, you can configure it like, I want my model to only flag its predictions in green, which is trustworthy. If the confidence, if the associated confidence interval for that specific diagnosis is between 90 to 100%. Anything other than that would either go into amber or fucking red. We don't care. So, that's something that gives user the power. So, So yeah, this is the application. I don't know how to stop saying, or I'm just trying to think if I've missed anything. Let me just clear all of this stuff up. yeah, no, that's it. So privacy first, simple data, you know, and also easily integrable with your common AI service providers. Now, the basis of this, the one thing I really want whoever is listening to take away from this, that it is indeed possible to bridge the gap between regressors and the traditional algorithmic machine learning models and sort of sophisticated AI stuff. You can use that sophisticated AI stuff as a preprocessor to your predictor. And that is one way, not the way, but one way to bridge that gap. And when you bridge that gap, what you get ultimately is quite powerful. You get a really cool descriptive data processor and sort of, recommender system, and the power of static rule-based prediction. There's something to be said about that. Anyway, so I'm going to stop this now. Enjoy, use this, drop in some suggestions. Just how do you think this could be better? And adios.